Today we are gonna do a quick revision of Python. So let's start with variable types. So in Python there are around four major variable types. So one is string, integer, float, and boolean. So here you can see I declared a variable called name and assigned it to a string called Alice. So similarly you can assign it age to an integer, height to a float, and you can see that each student is a boolean. Now let's see like how dynamic typing, can be explained in Python. So for example, in this case, you have x is equal to 5. So when you print this particular statement, right? So it says x is an integer, obviously because we assigned an integer to x. But once I reassign hello to x, which is a string, so you will be able to see that here the type becomes string. So basically, it's dynamically changing whenever I'm assigning a new variable type. So it's changing to that particular type. So this is simply called dynamic typing, which is a very prominent feature of Python. Um, so basically, it makes certain things easier in Python, but also you should be very careful when you are using this because in a function you might be doing some logic thinking that this particular variable will be an integer. But unfortunately, you might get some other variable type and your logic might not work as you expected. So there are solutions for that as well, but you should be very careful in using variables in Python. Now, to define a basic function, you just declare the name of the function, and you put def as part of basic function syntax, and you will put what are the variables that this particular function expects. In this case, this function expects two variables. One is a, another is b, and it returns the sum of a and b. So, for example, if you see result and print it here, it will be sum of 5 plus 3, which is 8. Now coming to this particular function. So there is something called as default arguments. Assume, for example, there are two variables to this function, but user might be able to send only one variable. Even then this function works as expected. So second variable should be given a default value so that if user doesn't send any value, it auto assigns that particular value that we defined here. So for example, in this case, when you're sending only Alice, name will be assigned Alice, but because there is no other variable, argument that we sent, so greeting will be assigned hello, which is the default value. So now you can see here the print will be greeting would be what the default value, which is hello, and name would be Alice, so it will be hello Alice. In this case, we are sending the two arguments as well. So here it would be greeting would be hi, and Bob would be the value for name. So it would be hi Bob. Now let's see, for example, there might be some use cases where you might have functions, but we don't know how many arguments that particular function expects. So you can use this particular syntax, which is asterisk and the name given to that particular argument. So user can send any number of values for this particular argument, and function should be able to work accordingly. So for example, for add, I am sending two arguments. So as we use this particular syntax, so it will be summing both 1 and 2 and your output would be 3. You can also send more values for this particular argument, which is in this case 1 2 3 4 5. So because of this syntax we can get the answer, which is 9 plus 3 12 plus 2 14 and 15 would be the answer. So just for your clarity, let me run the earlier one. And now if you see the next topic, which is kwargs, which is not nothing but keyword arguments. So for example, you might have multiple keyword arguments to be sent to a function. So for example, you will define in such a way that you will put two asterisk marks and give the argument name. So what you can do is user can send any number of keyword arguments and your function would be able to handle it. So for example, if a user send create user, in this case name is Alice, age is 25 and city is NYC. So your user data will contain all the arguments that user has sent and it stores it in a dictionary form. So you are getting the items, and for each item there will be a key and value. So you will say this particular key value is this. So in this case, name would be Alice, age would be 25, and city would be NYC. You can send as many keyword arguments as possible because you have used this particular syntax, which is double asterisk and your particular argument name itself. So let me run this. Here you can see, right? Whenever you're sending only three key value arguments, for the first statement will loop over all the items and their key value pairs, and you will see all the arguments values are printed here. Similarly for the next part as well. Now let's go to list. In Python, you will define a list by giving square brackets and putting the items in between that particular square brackets. So I am defining a fruits list here, for example, apple, banana, and orange. And you can access the elements of this list using indexing. So index will start at 0. So fruit 0 would give us apple, and -1 is nothing but the reverse. So which is the last argument, which is orange, would be what is printed here, because 0 is this and -1 is this and -2 is banana. Now, how are you gonna add items to a list? So you'll be using something called as append. So for example, if I want to add grape into this particular list, I will just put fruits.append grape, so which will add it at the end of the list. But I can also, insert at a particular index. So in this case, I'm inserting kiwi at index 1, which is what currently index 0 is apple, 1 is banana. So we'll be adding kiwi at 1 and banana will go to right. Okay. I let me just print this so that it would be, easy for you. So for example, when I'm adding, what is coming? I've added grape and also I have inserted kiwi. So as I mentioned, kiwi was inserted at index 1 and banana went to right, and grape was added at the end because append always adds items at the end of the list. Now you can also remove items. For example, if I can use remove function. So basically, when you do fruits.remove, banana will be removed. So here you see banana is not there once I removed it, but here you can see there is one more statement, which is fruit.pop. So pop is nothing but it removes item from the end of the list. So here, what is the end of the list? It's grape, right? So grape and banana will be removed, and you will have this particular list as the final list after removing. And what is the item that is popped? So pop function will return the item that is popped, so which is getting stayed in this particular variable. So you will be able to find that there as well. Now let's fastly, move to the next, which is list comprehensions. So basically, Python is very good at providing very concise syntax. So you can do something in just one line, which you need to maybe write 3 or 4 lines in C++, or you might also write 8 lines. So for example, here I'm declaring a list which is called 1, 2, 3, 4, 5. Now, what if I want to, for example, square all the numbers in that particular list? Normally, what you would do, you'll write a for loop, and you will write for each item you might do square of it, and put it in a new list, and you might print it out, right? But for example, in list comprehension, what you can do is just put the square brackets whenever, which we use to declare lists themselves, and for each number we are doing num power 2, which is just squaring that number for each number in numbers. So numbers is this list. So what we are doing is for each number in this, we are doing num square. So answer would be simply all the squares of these numbers, and that will be the value that is printed in squared. So let me just, run this. So you can see all the numbers are squared and the output is 149, 16, 25. Now, for example, there might be case where we only want to square even numbers. So what you need to do is just maybe filter, all the odd numbers, or filter only even numbers and square them. So in this case, what I'm doing, I'm putting a condition, which is the if statement. So whenever the number is divisible by 0, then only I am squaring that number. So basically, if number percent, in this case, modulus 2, which is the remainder, is 0, that means it's an even number. So if it is an even number, for each number, we are doing num square. So here you will see only even numbers getting squared. So which is 4 and 16. Why? Because even numbers are 2 and 4 here. So you will have only two values here. Now, There might be certain other conditions as well. Here we are only checking if it's even number or not. But if we can check if number is even, put even. If number is odd, put odd. So all the numbers here will be replaced by the word even or odd based on their condition, right? You can use any kind of complex logics and list comprehension. So here I have just given simple examples, for you to, revise this particular concept. Now let's go to dictionaries. So dictionaries in Python are declared using flower brackets, and dictionaries are nothing but you will put key and what is the value of that particular key separated by commas. So in this case, my user dictionary is having a name key or name attribute which whose value is Alice, and age 25 and email is a string. So you can use any kind of variable types in this particular dictionary. Now, how do I access a particular value from dictionary? For example, from user dictionary, I want what is the name of that particular user. You can use the name of the dictionary itself and square brackets and give the key name, which is name in this particular case, so that you would be able to get what is the value of that particular key. But here you should be slightly careful because there might be cases where this particular key itself is not there. For example, if user bracket x, because x is not there, it will return an error saying that this particular key is not available. So to handle that particular case, you need to write a conditional statement. Instead of that, better way is to use get method of dictionary, where you are getting the value of age. It checks age. If it's there, it will return that, or else it will return a default value. Okay. So for example, in this case, I'm saying user.get phone, but phone is not there. So we are saying if the particular key is not there, just return a default value which is not provided, which you can give to that particular function as the second argument. Okay, so let me just try to run this cell. So here you can see name is what, because name is already present, it's Alice. And if you see age, because age is present, it's 25. And now, because phone here in this case, phone is not available, so it will return not provided. Here you can see that value. Now, coming to, for example, I want to modify value of phone, right? Or I might add a new key here. So what you can do is simply, you will, in this case, phone is not there. So I'll put this particular square bracket and phone as the new key value I'm adding. And also I'll assign a particular value to it, and it will be added into the dictionary as a key value pair. And also you can update. For example, if you give a key which is already existing, you can assign it a new value as well. So this will give you, for example, user phone will be changed to, or here in this case it will be added, and then a value of it would be 1 2 3 4 5 6 7 8 9 0. Now coming to remove. For example, I can completely remove email, right, from this particular dictionary. How you do it? You will use the del keyword, and you put the name of the dictionary and what particular key you want to delete, you can delete it. And also, you can also use something called as pop method in dictionary. You can give a key which is present. For example, we have added phone here, right? So we have put in such a way that the particular value of the key will be popped out, and that value will be assigned to phone. But this will also be deleted from the dictionary. So here you can see once updated user is what, because we deleted user email as well as we popped the phone number as well. So it will be only just name and age. And removed, because we used pop, it will return the popped value. So the phone number can be seen here, but in this particular case. Now let's move to dictionary comprehensions. So as I said before, right, lists have list comprehension. In Python, you can also have something called as dictionary comprehension, which is a syntax which can help you in concise code. So in this case, for example, I have defined a list which is keys, and values which is another list. So in this case, for example, I'm creating a dictionary. So I have two lists. One is, maybe I'm assuming this as a key dictionary, and this is the value dictionary. I'll say first thing is you need to understand what does zip do. So basically, zip in simple language, it will create an association between both the arguments you have given. So for example, in this case, both the list, name will be associated with Bob, age would be associated with 30, and city is associated with NYC. So in this case, for example, we are zipping both these particular lists. As you know, k v would be what? K in this case would be name, which is the key, and value would be Bob. And you are saying you are just putting k as the key and value as v. So this will create a user dictionary. So let me run this cell. You can see this particular dictionary is created. Now you can also transform dictionary values. For example, I have a prices dictionary where I have fruits and their values. For example, I want to change prices slightly, right? So what I can do is I can get both the key as well as value, in this case item and price, using prices.items. So prices.items returns key value pairs. So in this case, I'm accessing both the key value pairs, and I'm putting for each item, I'm multiplying price by zero point 0.9. So these values will be multiplied by zero point 0.9, and you will see the new values that are present in this particular dictionary. So all these operations are happening within just one line of code. So if you see, especially in C++ or other languages, this might take more lines of code, and it might take more time than what is being presented in Python here. Now, this is with somewhat complex data structures. For example, I have an list which is actually a list of objects. So in this case, object is nothing but a dictionary which with key value pairs. Here the value might not be simple string, it might be again an array, right? So this is slightly complicated data structure. So you can simply use the same access techniques that we used for list as well as dictionary. For example, this is lists, so I will use index based accessing. So in this case, users of 0 would be what? That is the first element, which is this. Now in that I'm taking orders, because this is itself a dictionary. Orders will give me the value of this particular key, which is this. And in this, again, this is a list, so I am accessing the first item, which is this. Again, in this case, this is a dictionary, so from there I'm accessing total, which is 50.00. So let me just run this cell for you. Here you can see that particular value is assigned. Similarly, the other examples just provide you ways to access from this complex data structure. Okay. Now let's move to object-oriented programming. In this case, as you know, in Python, whenever you're declaring a class, you will use class keyword and give the name of that particular class, in this case car. And here we will define certain methods. So whenever a class is getting initialized as an object, your init method will run. So in this case, this init method will take two arguments, brand and color. So they are getting assigned the default values, which is whatever you are using when you are initializing that particular class. Okay. Now, if you see this, a brand and color are coming from the constructor, and the speed is assigned a default value of 0. Similarly, I define more functions. For example, I want to define an accelerate function. So for example, once you call this particular function, you might increase your speed. So by whatever amount we are accelerating, we are increasing the speed of that particular car that we have instantiated. Now brake is what we are stopping the car, so you're putting speed as 0. So simply, how would you instantiate a class or create objects? So in this case, you will use the name of the car, class itself, which is car, and it requires two default keyword values that are declared here. So in this case, Toyota and red, so they will be assigned accordingly. Similarly, your car, here you are again putting one is, for example, brand is Honda and color is blue. Now, once this particular object is created, you can just call the functions which are present in this object, in this case accelerate, and give the amount. And all these functions act similar to the previous simple functions we have defined. Now, for example, in this case, there might be few issues, right? So that particular part is explained here. Here again, the car class is defined. Assume speed is a private attribute. In Python, there is no strict differentiation between public and private attributes. So you can, like for example, in C++ or somewhere, you can say this is a public variable and is private variable, and public variables are accessible outside functions, sorry, outside classes. But private variables cannot be modified by anything outside that particular class or class member, right? So here in Python, to just indicate that this is a private attribute, you are putting an underscore before the variable name itself, which actually, is a convention in Python to declare private attributes. For example, in this case, this function speed, what it does is it gives us what is the current speed of the car. So here, this property decorator, what you call here, this says that this particular is a property declaration. So you can just not even call the function whenever you say, for example, car dot speed, which is underscore speed without any square brackets. You can get it as just a value of this particular object. Now speed dot setter. So this is setter. So this is a setter declaration. So what does this mean is this particular function helps in setting the value of that speed. So for example, I am giving if value is less than 0 because speed cannot be negative, you are raising error. If speed is greater than 200, speed is too high. So and you are assigning that particular speed value here. Why we are doing this? Because if there is no condition on assigning a particular speed, what happens, user can assign any invalid speed amounts. Here in this case, there is no way you can actually stop user from assigning any speed that he thinks he wants to assign. So here you are putting certain conditions so that user can't assign speeds which are out of values that you allowed. Similarly, accelerate is a function which is similar to the previous one, where you can set the amount of acceleration and speed would be increased. So here, similarly as the previous case, we are declaring an object. Sorry, we are instantiating an object which is car with Toyota and red for the default values, and you are assigning car speed. Now the question is, when I assign this speed is equal to 50, so will it be assigned or not? Yes, it is assigned because whenever you call this speed, you don't, even though it is a function that is declared in this particular class, as I mentioned, these decorators help you in making them look like they are just a property values that you are assigning. So this is allowed, and car speed gets updated through this particular function. But when you are trying to assign a speed of -10, again this function gets called because of this decorator, and because its value is less than 0, this particular will raise an error. So let's just see. So now initially when you are assigning 50, it's 50, but when you are uh, assigning a value which is -10, it is coming as a negative value. So these kind of decorators are very useful, especially when you want to not directly make user freely assign any value that he wants, which can make this particular object slightly invalid in real use case sense. Now for example, in cars there might be different kind of cars, right? So what I will do is, for example, in normal cars, what we'll have diesel cars, petrol cars, electric cars, and there might be some other weird cars as well. So I'll define a base class, which, for example, will have a constructor which initializes our brand, color, and speed. And obviously, we have an accelerate method which we described below. And also, we'll have a simple describe method which says, like, for example, what is the color and what is the brand of a particular car. It just prints or returns that particular statement. Now, I will define one more car, which is an electric car. So it's a subtype of car. So every electric car is a car, right? So here we use something called as inheritance. Electric car is a child of car class, so it inherits all the methods that are declared in the child class. Now, when you are initializing this electric car, for example, what you need to give? You need to give brand, color, and also because electric cars have battery capacity. So first thing is brand and color. You already have a you know base constructor in the base class, which is assigning brand and color. Here for example, brand is equal to brand and color is equal to color, right? Whatever color you have used where you are instantiating that particular class. So I am calling in this case super is nothing but it will call your parent class in this particular case. So car is the parent class for electric car. So we are sending brand and color, which is actually the values that this constructor for from car class will take. And now for this class, because battery capacity is unique to it, we are assigning that value. And for example, in this case, I'm assigning 100. Okay, so that battery level is also assigned. Now, charge. So I am defining some special functions which are specific because you can't define charge function for maybe petrol cars, right? So these are unique functions which are relevant to this child class. So they are defined separately here. For example, I'm putting, you're putting charge, you're putting battery level to 100 and you're just printing that. Similarly, you're describing because electric cars also have battery capacity. First thing is you must see base description is what kind of car this is already defined in base class. So that, as I mentioned, using super you're calling base class and describe function there which takes color and brand, right, which you already have. So that will be added. From there you'll getting base description. Then you are adding the remaining parts of the description which are specific to electric cars. So if you see, I'm declaring a regular car. So which this particular constructor gets called, right? Now I am defining electric car, which is nothing but electric car with Tesla white, and we can also give what is the battery capacity. So that will be instantiated. Now if regular car is described, what will be called? Obviously this particular function. But here in electric car, we have some additional functionality to describe that can be used as well. See here, white Tesla and electric, how what is the battery capacity that also is getting added here.